Hello, and welcome to the Identification of Stereocenters tutorial. This tutorial is a review of stereocenter identification. The most common type of stereocenter is an atom that is bonded to 4 different substituent groups. In organic chemistry, that generally means we're looking for an sp3 hybridized carbon atom with 4 different groups bonded to it. An example of a stereocenter is the central carbon atom in the following molecule. We will begin by practicing finding the stereocenters together in a couple molecules or ions, and then I will have you practice those skills on your own. The first structures we will work through together are the following. These structures look very similar, but let's work through them one at a time, starting with the molecule on the left-hand side. We will begin by adding all of the implicit hydrogen atoms to the skeletal structure. For example, we know that these 3 carbon atoms cannot be stereocenters because they each have 3 of the same group, hydrogen atoms, bonded to them. We can also see there is 1 carbon atom bonded to 2 hydrogen atoms. Therefore, we know this cannot be a stereocenter. Which other carbon atom can we exclude for a similar reason? We can exclude the carbon double bonded to the oxygen atom because the carbon is not sp3 hybridized, thus it cannot be a stereocenter. We have 1 more carbon in the structure. Let's take a look at all the substituent groups bonded to the carbon. We have a hydrogen atom, an ethyl group, a methyl group, and a carbonyl group. There are 4 different substituent groups. Thus, it is the only stereocenter in the molecule. Now we will look at the structure on the right. Again, we know the methyl groups at the ends cannot be stereocenters because the carbons are bonded to 3 hydrogen atoms. The CH2 groups next to them can also not be stereocenters because the carbons are each bonded to 2 hydrogen atoms. The carbon in the middle of the molecule is the only one we have left to study. This carbon is bonded to an ethyl group on the left and an ethyl group on the right, the hydroxyl group, and a hydrogen atom. Because the carbon is bonded to 2 ethyl groups, the carbon is not a stereocenter. Therefore, this molecule contains no stereocenters. We will look at 2 more structures together. Again, we'll begin by looking at the structure on the left. If we draw in the implicit hydrogen atoms in this molecule, we see that all the carbon atoms are bonded to 2 hydrogen atoms except for the carbon bonded to the hydroxyl group. So we will investigate this carbon further as it is the only carbon that can possibly be a stereocenter. The carbon is part of the 6-membered ring, so to determine whether or not it can be a stereocenter, we must look at the 2 halves of the ring, starting with the carbons bonded directly to the carbon of interest. These carbons are both CH2 carbons, and therefore are the same. We'll move to the next carbons in the ring. Again, these carbons are both CH2 carbons, and therefore are the same. When we move to the next carbon, we see they're at the same carbon, and this is the same carbon for each substituent. This tells us that both halves of the ring are identical, and therefore the hydroxyl carbon is bonded to 2 identical groups and as such is not a stereocenter. There are no stereocenters in this molecule. Now we will focus on the other molecule. Again, in this molecule, we see 1 distinct possibility for a stereocenter. Let's draw in the implicit hydrogens. With these, we can see that 3 of our carbons are bonded to 2 hydrogens each, and our other 2 carbons are bonded doubly to another carbon. Therefore, they are not bonded to 4 different substituent groups. Therefore, the only possibility for a stereocenter is the carbon where the hydroxyl group is bonded. This carbon is also bonded to a hydrogen group and 2 carbons. Just like we did in the previous example, we will travel through the carbon bonds to see if there is a difference in the carbon chains. The first carbons are the following. When we go to the left, we have a carbon atom double bonded to a carbon atom. But when we go to the right, we have a carbon atom single bonded to a carbon atom. So there is a difference in the two halves of the ring. Thus, these are considered different groups. Therefore, we have a stereocenter at the carbon atom bonded to the hydroxyl group. I think it's time for you to put those skills to good use. Here is how this is going to work. I'm going to give you a structure. You will pause the video, draw the structure, identify all of the stereocenters in the structure, and then play the video back to check your answers. And here is your first molecule. Remember to pause the video, write down the structure, identify the stereocenters, and then play it back to go over the answers. Please pause the video at this time, and good luck. Welcome back. Remember, when looking for stereocenters, we are looking for atoms with 4 different substituent groups. So all of the carbons that are double bonded cannot be stereocenters because they are bonded twice to the same thing. All of the methyl groups bonded to the structure cannot be stereocenters because they are bonded to 3 hydrogen atoms. When looking at the carbon atoms that are not circled, we can see several carbon atoms in the ring without double bonds or other substituent groups, but they are bonded to 2 hydrogen atoms. So these carbon atoms can also not be stereocenters. We have 3 carbon atoms left that can be stereocenters. We will start with the carbon atom on the left. This carbon is bonded to a methyl group, a hydrogen, and is part of a ring where the 2 halves of the ring are different. Therefore, this is a stereocenter. Let's look at the next carbon atom, working left to right. This carbon is bonded to a methyl group and is part of 2 different rings. For each ring, the 2 halves of the ring are different, so this carbon is bonded to 4 different groups. Thus, it is also a stereocenter. And let's look at the last carbon atom. This carbon is bonded to a hydrogen, the alkene group, and is part of a ring where the 2 halves of the ring are different. Therefore, it is a stereocenter. In this molecule, we have the following stereocenters. I have another molecule for you to practice on. Remember to pause the video, draw the structure, identify all of the stereocenters in the molecule, and then play the video again to verify your answers. And here is the molecule. Please pause the video at this time, and good luck. Welcome back. Let's go over those answers you have. We'll start by eliminating all of the carbons that are double bonded or bonded to 2 or more hydrogen atoms. We can also eliminate all of the nitrogen, oxygen, and sulfur atoms because they are not bonded to 4 different groups. To make this easier, we will draw boxes around the atoms that could be stereocenters after we eliminated all of these atoms. As we look at each of the atoms in the purple boxes, we are looking to see if the atoms are stereocenters. We will make sure each of the atoms is bonded to 4 different substituent groups. Let's look at the carbon atom bonded to the amine group. Let's draw in the explicit hydrogen for this carbon atom. Here are the 4 different groups bonded to this carbon atom. Now we will look at one of the carbon atoms in the ring. Let's draw in the explicit hydrogen for this carbon atom. I have circled each of the 4 different groups bonded for this carbon atom, therefore making this a stereocenter. And if you continue to do this around the rest of the ring, you will verify each of the stereocenters we have already identified. I have one last molecule for you to practice on. Remember, pause the video, draw the structure, identify all of the stereocenters in the molecule, and then play the video again to verify your answers. And here's the molecule. Please pause the video at this time, and good luck. Welcome back. Let's go over the answers. We will begin by eliminating all of the atoms that are double bonded or are methyl groups. We can now remove any of the atoms that are bonded to 2 hydrogen atoms. Let's make this easier to look at by selecting the atoms that are still in the running for being a stereocenter. We remember from earlier that a stereocenter is an sp3 hybridized carbon that is bonded to 4 different substituent groups. If we were to look at all of the boxed carbons as we did in detail with the previous molecules, we would find that all of the boxed carbons are stereocenters. Thank you for watching this tutorial. Feel free to watch the other tutorials, and good luck.